Hello and welcome back to our microcontroller labs video. In this video we are going to discuss and look at how we can control the direction of the motor using a push button. And with this push button, when one push button is pressed, the motor should operate in a clockwise direction, and when button 2 is pressed, the motor should operate in a counterclockwise or anti-clockwise direction. And our component that is needed for this particular setup, we need the Arduino Uno L293D motor driver IC, and we need a DC motor 2 times the push button and two 10 kilo ohm resistor for the purpose of pull down, and we can have a power supply for the circuit. And also we are going to discuss how we can be able to control the speed of this particular DC motor using a pulse width modulation. And in our Proteus design sheet, we are now going to collect our component. We have our Arduino Uno. We can have L293D drivers for controlling our motor, and we can have the push button, and we can collect our resistor, and finally we can have our DC motor. And those are the main components that will be used in our project. And now we can begin by building the circuit. And you can place your Arduino Uno, and we can have our drivers. Let's connect our drivers. We have our DC motor, and you can connect as follows. And since this is a 12 volts DC motor, we can add the power supply. Let's give positive 12 volts, and we have the power supply to the 293D H-bridge drivers. We can give positive 5 volts, and we have the ground, and we can connect the input 1 to pin 6, and we have the input 2 to pin 5. And now to control the speed of this motor, we will use this enable pin to connect to the PWM pin of this microcontroller, which is the pin 9 of this Arduino. And with this enable pin, we should be able to use a pulse width modulation to control the speed. And previously we apply a 5 volts, which have a decimal value of 255 in terms of the pulse width modulation. That means this particular will operate in a full mode or full speed, because when we apply a 5 volts to this enable pin, it should operate in its full speed. However, if we want to decrease the speed, that means we want to control the speed of this DC motor, we will supply a decimal value which is less than the 255, which is the 8-bit pulse width modulation. And once this is complete, we should now configure our push button. And we have the push button. We should have push button 1 and push button 2, and we can connect the pull down resistor, which will aid in the operation of the push button. And we can have the ground and the power supply for the input signal to control the speed, and we have positive 5 volts and we have positive 5 volts. And now we can begin the connection to the Arduino. And this is button 1 for clockwise direction. We can connect it to pin 2, and we have pin 3 which we should connect to push button 2. And this will be the clockwise direction control, the button 1, and this button 2 will be the counterclockwise rotation control for this particular DC motor. Later on in this video, we should be able to integrate some displays such as the LCD, LED to tell us the direction as a physical interface for the user to realize that when the motor is in a clockwise direction, there should be an LED or a display, and when it is operating in the anti-clockwise direction, we can have this push button press, and we can have the LED or a display that is showing that this motor is operating now in the counterclockwise direction. And I think our circuit is complete. We can now continue to our Arduino IDE, and we can now program how we can be able to use these two push buttons to control the direction and the PWM signal to control the speed of this particular DC motor. Now you can open up your Arduino IDE and we can start to program this Arduino microcontroller. We now have our Arduino IDE open. We can now zoom this a little bit so we can be able to physically see the pins and the connection, and from there we can be able to program. And firstly, we can now discuss and write the motor control pins, and from there we will now be able to initialize the pin and the connection, and we can give a constant integer value to the variable in1 which is connected to pin 6, and we have another pin which we give it having an integer value, let's say in2, which is now connected to pin 5 of this Arduino, as you can see from the circuit diagram. And we have the constant int. We are giving the variable which say enable for the PWM. Let's see, it is connected to pin 9 of this Arduino Uno. And now for our 8 bridge connection is complete, and now we are going to look at the buttons. And for this button we also have a constant integer to the variable, let's say button clockwise, and it is connected to pin 2, which is the first button. And we can have another variable constant integer, let's say button and counterclockwise, and it is connected to pin 3 of this Arduino Uno. And now we successfully initialize both the 8 bridge drivers and the button connection. Now under void setup, we will declare which should be the input and which should be the output pins. And firstly, let's go to pin mode, and we can say in1, which is our output. That means pin in1, which is the pin 6, will act as a output pin. And similarly, pin mode, let's say in2, which will also be our output. And we have finally pin mode enable which should be our output pin as well. It will output the pulse width modulation signal. And we have also the input pin such as the pin mode, and we have the button clockwise, which will now be our input pin, because this pin, which is pin 2, will mostly accept a signal from the push button. And also pin mode, we can say button counterclockwise will also be our input pin. And now we successfully declare the pins as an input or an output pin. And we can now be able to say that during startup is when the microcontroller is switched on. That means since we are now using a button, we want that during the startup the motor must be switched off. And in that case, otherwise, if we did not specify, the program will directly execute the program under the void loop. And in that case, we want that there should be no input and no output to be accepted during the startup. And from there we can be able to say digital write, and we can say IN1 must be low, and also we can say digital write IN2 must be low, because in a case where if someone is switching on the push button, or the push button is pressed during the startup, the motor will automatically run in any direction based on whichever button is pressed. Switch on, that means the motor must not operate until after a specific time. We can now be able to control this particular DC motor, and in that case we can also say that the PWM enable, which is having 255, which is the maximum value of the PWM at full speed. And let's give a delay of 1000 milliseconds. So during the startup, after 1 second, we can now be able to control the operation of the DC motor by controlling the push button to control the motor direction. And if you want to increase the duration of the startup, where both the input is low, you can increase the delay. And this delay is the timer of the circuit. And inside this microcontroller, we have the timer which manages the delay. And now I think we are complete. And after this 1 second, we can now be able to program our void loop. This is the actual control of the operation. And in that case, we are now be able to read the button state, where the button is high, will send a 5 volts signal to the input of this Arduino Uno. And from there we can say the state can be 1 or the 0. And in that case we give a Boolean data type such that, let's say, CW press. That means if the button which is pressed in representing a clockwise direction, then this can be a digital read. And we have the button clockwise, and we can also have the Boolean and counterclockwise press, and it is equivalent to the digital read, which is the button counterclockwise. And since it is a digital read, because we are having a 5 volt supply, when the first button is pressed for the clockwise direction, then the Boolean will be 1, and if it is not pressed, then this variable CW press will represent a Boolean of 0. and same for the counterclockwise press, because we are only reading a digital data. And once this is done, we can now be able to compare this particular value. And in that case, let's say case 1, and for this case 1 we say clockwise button press. And in this clockwise button press, we know that this particular button will be switched on, button 1. And in that case, we can now say if the clockwise press, and we can do a comparison using a logical operator, which is the AND. And we can have if not counterclockwise pressed, then we can have a statement which is the digital write IN1 must be high, and we can have the digital write and IN2 must be low. And with this code, we can now be able to see that we are using a logical AND operator such that if this is true, if this button is pressed, which is the clockwise direction button is pressed, and not the counterclockwise direction, then we should have the input 1 must be I, which is IN1, which is the input to the input 1 pin of this particular H-bridge drivers. And the second one, which is the IN2, which is the input to this particular drivers, pin 7 of this particular drivers must be low. And in that case, when this one is high, then the motor will operate in a clockwise direction. And if the IN2 is high and IN1 is low, we know that the motor will be operating in the anti-clockwise or counterclockwise direction, like what we have seen in our previous video. And now this is case 1 where the motor will operate in a clockwise direction. Now let's say we have our case 2, and in this case 2 we can see that if the counterclockwise button is pressed, then what will happen? And we can see that we'll add else is, because when we use if and else is, that means one button will be pressed at a time. And in this case we have if counterclockwise pressed, and we have not the clockwise pressed, then what should happen? And in that case we can have our digital write where we have the IN1 which must be low, and we can have a digital write in which IN2 must be high. So this motor should be able to operate in the anti-clockwise or counterclockwise direction. And after this is our conditional statement for controlling the direction, and we can add a small delay for, let's say, maybe 50 milliseconds. This type of delay is mostly considered as a debounce delay of the button. We can say debounce of the button. And now I think our code is complete. So we have initialized those particular pins corresponding to the Arduino, the drivers, and the push button. And under the void setup, we now declare whether the pin of this particular Arduino will act as an input pin or an output pin. And this is during a startup. That means for 1 second when the microcontroller or the system is switched on, nothing should be happening. And after this, we are now be able to read the button such that we are giving a boolean representation of the variable CW press for a clockwise direction control using the push button 1, and we also have CCW press, which represent a variable that will store 1 or 0 for the push button 2 to control the motor in the counterclockwise direction. Because we are using a boolean, we can now be able to use a logical operation of the particular microcontroller. And from there, when the button is pressed, it should be 1, and if it is not pressed, then it should hold 0 because it is a boolean data type. And from there, when the input 1 is having a positive 5 volts applied to it from the pin 6 of this Arduino Uno, the motor will be operating in a clockwise direction, because the signal that is to control this motor to operate in the clockwise direction will be generated from these H-bridge drivers. And also for the IN2, when the counterclockwise button is pressed, then we can have the input 2, which should be I, which is the IN2 of these H-bridge drivers. And from there, it can also generate a signal to control this particular DC motor to operate in the counterclockwise direction. And we can now be able to compile to see if there are some errors in our code, so we can modify it. And we have the pin mode button CCW, so you can be able to see that this is the error. So we can have a capital letter CCW. Now let's compile again. And remember that those programs are case sensitive, so when there are some mismatch in the names or the variable that we declare in our code, there will be errors. So all of this must match. So since we have no errors, we can now export the compiled binary, which is our hexadecimal data that is needed for the Arduino Uno. And now we can go to our Arduino Uno, and we can go to our code, and we can now import. And now this is our circuit. We can now be able to simulate to see how it will operate. So during startup, after 1 second, we can now be able to control. And since we are using the analog write, which is the 255, which will enable this motor to operate in a full mode, that means the speed is at its maximum. Now let's press the push button, so we can now be able to see that this motor is operating in a clockwise direction, and we have a positive which represents the scenario. And when we leave the push button, that means it will stop. However, it is keep rotating because it is a DC motor. However, this motor is not operating anymore. If there is an inertia applied to this motor, it will stop at that instant. And when we stop this particular operation, we can now see if we press the push button, it will now be able to operate in the counterclockwise direction. So when we release the button, that means there should be no more operation done to this particular DC motor. And again, if we now press to the clockwise direction, it should now be able to operate in the clockwise direction. And from there we can be able to see that how we can be able to use a push button to control the direction of a DC motor. And this is very important in many projects if you decided to use a DC motor, and if you want to enable a control for this particular DC motor, you can interface it with a push button. And now we can be able to see if we decrease the speed of the particular DC motor. Let's give 1 to 8. And from there we can be able to see this motor will operate in the direction which will have the speed corresponding to the 1 to 8. That means we will configure, because it is an 8-bit, we can now decrease the speed of this particular DC motor, and we will continue to decrease to see how the speed will operate. Let us compile, and once it is done, we can export the compiled binary. And we will continue to decrease the speed until this motor will be less speeder in either clockwise or anti-clockwise direction. Now let us see. Now we are turning it in the clockwise direction, so we can be able to see the speed. It is quite less in the clockwise direction, and if we want to control in the counterclockwise direction, we can also be able to see that the speed is not that fast as previously in the full mode. And now we can be able to see if we are running this motor, let's say 32, we can compile. And we can export the compiled binary again, and the speed will become less and less corresponding to this value. And let us run the simulation again. Now you can be able to see that the motor is, although in a clockwise direction, however the speed is reduced. And also we can go to the counterclockwise direction. We can now be able to see that the speed is gradually decreased. And if we apply a 0 here, that means what will happen? That means the PWM signal is 0. And although the push button is pressed, we won't be able to have the speed, because the speed is currently 0. It's not at the maximum and not at the minimum, but it is off. And now let's try this. Let's click the clockwise button. We can see that nothing is occurring at this motor. For the anti-clockwise, there's nothing happen. So we can appreciate that to control the speed of this motor, we now using the PWM signal to control the enable pins of this driver. And we can appreciate that by using a push button, we can be able to control the speed of this particular DC motor. I believe with this video you can be able to appreciate how we can control the direction and the speed of the DC motor using a push button. It will be helpful for you in the future if you are eager to design system which can control a real-life application. And if you like our video, you can kindly like and subscribe to our channel, and also share this video with your friends so they can also be able to learn and grow. And if you have some question, you can write us a comment in the comment box so I can be able to respond to you immediately.